Part 7, exercise 10.4, NCERT. There are two circuits intersecting at each other, and the distance between the centers is 4 centimeter. The radius is 5 centimeter and 3 centimeter. So this bigger one will have 5 centimeter, obviously, and this smaller circle will have 3 centimeter radius. And the distance between O to O dash from here 4 centimeter till O dash. Okay. Find the length of the common chord PQ. We have to find the length of common chord PQ. So suppose this is L point where this O dash and PQ intersect. That is point L. Okay. If we take this L to O dash, this length we are taking as X. O dash, let O dash L is equal to X. Then what will be OL? OL will be 4 minus X because we have subtracted from X. This will be 4 minus X till here. Okay. And you know that the line joining will be perpendicular to the chord to the center. So OPL is a right angle triangle. So in right angle triangle, first in right triangle PLO, you can use the Pythagoras theorem. By Pythagoras theorem, which will be the hypotenuse? This is 90 degree OP. OP will be the hypotenuse. So OP square will be equal to OL square plus PL square. And OP is 5 centimeters. So 5 square. OL is equal to 4 minus X. This is OL. 4 minus X whole square plus PL square that we need to find because common chord PQ we have to find. So PL, once you get the PL, you can multiply by 2 to get the PQ because the perpendicular from the center to the chord bisect the chord. So therefore from this equation we get the value of PL square as, to bring this side that value, so 5 square, you can write 25 minus 4 minus X whole square. This is your equation number 1. And now right hand side you have another right triangle P L O dash, P L O dash. This is O and that is O dash. So in this triangle, again by Pythagoras theorem, we get what is the hypotenuse? Perpendicular, opposite to the perpendicular. This is perpendicular, so O dash P is the hypotenuse. So O dash P square is equal to PL square plus O dash L square. O dash P is the radius, 3 square, PL square, we don't know. O dash L is X, so X square. So from this equation, we get the value of PL square as 3 square 9 minus X square, second equation. Okay, now from first and second, both are giving the values of PL square, so we can equate. So from first and second, we get 25 minus 4 minus x whole square is equal to 9 minus x square. Solve it. 25 minus 4 square 16a square plus b square minus 2ab, 2 for the 8, x is equal to 9 minus x square. So 25 minus 16 minus x square plus 8x is equal to 9 minus x square. And this minus x square will cancel with minus x square. So we get only 8x is equal to 9 minus 9. 25 minus 16 is 9. So 9 minus 9, 0. So x, we get x is equal to 0. That means O and O dash, O coincides with L. X is equal to 0 means O dash is on L. O dash is not beyond L. O dash will be on L. O dash coincides on L. Once it coincides on L, that is O dash P will be equal to PL because O and P will be same, and O dash P is 3 centimeter, therefore PL will be 3 centimeter. So PL is 3 centimeter, therefore PQ is equal to the double of PL because this bisects the chord perpendicular from the center on the chord bisects the chord. So 2PL, so 2 into 6, 2 into 3 is equal to 6 centimeters is the length of the common chord. Okay, got it? Two equal chords of a circle. So this is the circle, one circle. In this we have given the two equal chords. So this is, let's take one chord. This is one chord and another chord is equal to this chord. Another chord is suppose you can draw from this point to this point. Okay, these are two equal chords. Maybe it is not looking like, but I'm trying to make it equal. That's not okay. That's so these are the two equal chords, AB and CD. This is suppose AB and CD are two equal chords intersecting at E point, and this is the center of the circle. Suppose then we have to prove that the segments of one chord are equal to the corresponding segment of the other chord. Means we have to prove one segment is AE will be equal to DE. Means this part we have to prove equal to this AE equal to DE, and second part is what, BE and CE. So and we have to prove CE is equal to DE. So draw perpendicular OM. Draw perpendicular from O to AB. This is the perpendicular from O to AB, and another perpendicular from O to CD. This is center O, and draw perpendicular OM and perpendicular ON. Okay, so we can write here construction Draw OM perpendicular on AB and ON perpendicular on CD. This is also perpendicular on CD. Okay. Then join this line OE also. Join OE. OE. Okay. Now we have to consider these two triangles OME and ONE. You see in these two triangles, we can use RHS. We can use RHS in these two triangles to consider these two triangles, right triangles. In triangle OME and triangle OME and triangle ONE. ONE1. This is 90 degree. One angle is RHS. First, you have to show the 90-degree angle, one angle. So OME and ONE is equal to 90 degree. R. Hypotenuse is this side. This is the common side. So OE is equal to OE because this is common side. RH and one more side, that is the radius. OM and ON are the radii of the same circle. So OM is equal to ON because these are the radii of same circle. So therefore, we can say by RHS congruency, triangle OME is congruent to triangle ON. When it is congruent, then ME will be equal to NE. This ME will be equal to NE by CPCT. ME will be equal to NE. This we got by CPCT. Okay. Now, you know that AB is the chord and OM is the perpendicular dropped from the center, so it will bisect the chord. So AM, and also given that we have given that these are the equal chords. We forgot to write that it is given that the chords are equal chords. That means the length of AB is equal to length of CD. It is given. We can use it. Now, since AB can be bisected by AM, so we can say that AM is equal to MB, and similarly CN is equal to ND. So that means AM is equal to MB means, but AB is equal to, so half of AB is equal to half of, if you will write AB is equal to CD, so half of AB is equal to half of CD. We can write, it is given. So half of, what is half of AB? Half of AB will be equal to MB. And half of CD will be equal to NC, yeah, CN, same thing, NC. Question number 2. Now you have to prove EB. BE is equal to CE. BE is equal to CE first. So MB, if you will subtract from MB, means second from first. Just simply subtract second from equation number 1. So second is this MB minus first equation is ME is equal to NE. When you will subtract MB minus ME, it will be equal to BE, correct? BE, and similarly here CN minus NE will be equal to CE. So we got this proof. CE is equal to BE. Proved. One thing proved. Second, we have to prove that AE is equal to ED. So it's obviously AM is equal to NE. Then we have proved that CE and ME is equal to EN. So ME can be subtracted from this. So AM is equal to ND because the chords are equal and this will bisect the chord. So this part ND will be equal to AM. Why? Because the chord equal chord, because of that equal chords. Okay. And ME is equal to NE. From first equation we can add both sides, ME, one side NE, one side ME, one side NE. We can add here, if you will add AM plus ME, this side we can add ME, and right side we can add NE, because both are same, we are adding the same thing. So this from first we have added both the sides. So AM plus ME is equal to AE, and ND plus EN is equal to DE. That is the first part that we have to prove. So we got both the proofs. Question number 3, 2 equal chords. So as in the question given equal chords, so AB is equal to CD. These are 2 equal chords, and these are 2 equal chords. You can see this chord and this chord. They are equal chords within the circle, intersecting within the circle. So we have to draw like this. If it is not given intersecting, we can draw here and here 2 equal chords. So that's why it is always given intersecting within the circle. Prove that the line joining the point of intersection to the circle makes the equal angles. Joining the point of intersection is E to the circle. Prove that the line joining the point of intersection, this is E, point of intersection, makes equal angles with the chords. Means this angle we have to prove equal. Okay, got it? Now, okay, so it's easy, that we have done before also, same the previous one. In this again we will consider these 2 triangles OME and ONE. So if you want, you can write the given condition, what you have to prove. So we have given a circle. We used to write like this. I'll write CRO, means radius R in the center, such that AB is equal to CD. Okay, and 2 chords intersecting at E, AB and CD chords intersect at E. And construction also, we have done some construction, so you can write construction also, because this is the given condition only. Construction we have done, draw OM perpendicular to OM perpendicular on AB, ON perpendicular on CD, and also join OE, join OE. And to prove that, we have to prove that angles are equal. Which angle? This line is making with the chord. The line which is making with the chord, angle 1. We have to prove angle 1 is equal to angle 2. Okay, so we will consider these two triangles. In right triangle, in triangle OM, in triangle OME, and triangle ONE. Yes, someone is saying something. Slow down. Okay. See again. Okay. I'll explain slowly. Angle 1, we have to prove angle 1 is equal to angle 2. Okay. Angle 1 means the angle which the point of intersection joining the center makes with the chord. This is the chord, this side AB, and this side another chord. So this angle we have to prove. And ON drawn perpendicular. We are taking OME triangle and ONE triangle, and using RHS formula. So angle OME is equal to angle ONE is equal to 90 degree, each 90 degree. So 90 degree means right triangle. RHS first 90 degree, then hypotenuse angle, then side opposite to the angle 90 degree is hypotenuse. So opposite to this is OE, and opposite to this is also OE. So therefore OE will be equal to OE. Why they are equal? Because they are common sides. Okay, and this 90 came by construction because we draw the perpendicular, so by construction. So this is RH, and one of the side you have to show equal. So this OM is the radius of this circle. No, not radius, sorry. OM is the perpendicular from the center to the chord. The length of perpendicular from the center to the chord, two equal chords are equal. Yes, I think I have told in the last one. Also, you can correct it in the previous question. ON is equal to OM is because the distance of equal chords from the center are equal. Equal chords are equidistant from the center. You can write equal chords are equidistant from the center. Equal chords are always at equidistant. So therefore, by RHS congruency, this triangle OME is congruent to triangle ONE. Once it is congruent, then every part is CPCT are equal. So therefore, angle 1 will be equal to angle 2. Finish. Angle 1 will be angle 2 by CP, CP. Improved.